nano or non-nano, many people are talking about the potential danger of nanomaterials. But still, almost all the companies are still using nanomaterials only for their sunscreens product. Today, we're going to walk you through the reasons behind this weird situation and then possible solution we are proposing as a company. Introduction for real non-nano zinc oxide particle technology is the technology we have been working on, and we call this giant shift from less harmful to more beneficial solution. My name is Jay Lee, and I'm a CTO and CEO of Toxicologists Corporation. Today, first of all, we're going to actually talk a little bit about regulatory guidelines for the nanomaterial. Second, and then we're going to also talk about what is going on in the market. Some of the people are actually taking advantage of non-nano concept while they're still using just nanomaterials only. And then third, we're going to actually discuss more about the journey for the real non-nano technologies that we have been working on, also others' efforts too. According to ECHA, nano can be defined as just like this. 50% or more of particles in number-based size distribution have to fulfill one of the following conditions. There are two other conditions, but that's exceptionally extreme exceptions. So we're going to actually talk about just first condition. One or more external dimensions of the particle should be between 1 nanometer to 100 nanometer. So anything smaller than 100 nanometer is nanomaterial. When it comes to the particle, it definitely is a primary particle. However, if it is bonded strong or infused particles, then the group itself can be treated as a particle. So any primary particle smaller than 100 nanometer, or any group of a particle that is smaller than 100 nanometer is nanomaterial. In the European cosmetic guidelines, they actually have more guidelines about using nano titanium dioxide or nano zinc oxide, just like this. Important figures right here is 330 nanometer. Even if you can still use nano zinc oxide or nano titanium dioxide, but you have limits because it has to bigger than 30 nanometer for titanium dioxide and also 30 nanometer for zinc oxide. For zinc oxide's case, even if it is bigger than 30 nanometer in general or on average, if the 1% of the particle distribution is smaller than 20 nanometer, then you cannot use it in the cosmetic uses. So you can use nanomaterials, but for the cosmetic use of nanomaterials, the particle size, primary particle size, have to be bigger than 20, 30 nanometer all the time. If not, it's illegal to actually use. Okay, this is just like a simple examples of what is nano and what is not nano. According to the nano definition, as I mentioned in the previous pages, all the dimensions have to be above, bigger than 100 nanometer in order to be non-nano. So if there is a particle just like this, all three dimensions are bigger than 100 nanometer, it's non-nano. It's not nano at all. And there's another way. If the primary particle itself is as big as this, it's non-nano clearly. However, if the small particles has a group bigger than 100 nanometer in all three dimensions, it is also non-nano too. There's another shape like this. It's like a planetary shape. So all two dimensions, like X and Y dimensions, usually in that case, it's bigger than 100 nanometer. So it's not nano, but the thickness is like a 20 nanometer. And then this is nano, because in the previous definition, if any one of the more external dimension is smaller than 100 nanometer, it's nano, right? So in this case, even if two dimensions of the bigger than 100 nanometer, still the thickness is less than 100 nanometer. So it's still nano by the definition of ECHA. However, it's a two-dimension non-nano, as I define. And there's another shape of zinc oxide. It's called like a columnar shape. In this case, X and Y dimension, two dimensions below 100 nanometer, so it's nano, clearly nano. But the length or thickness is bigger than 100 nanometer. So of course it's nano by the definition of ECHA. However, we called it like a one-dimension non-nano. The reason why we actually separating, those kind of partial non-nano products from pure nano products is that there are some researches have done to compare just nanomaterials with these partial non-nano materials about the danger of the potential danger of use, actually. Yeah. So if you go for any nanomaterial shaped just like this, and if it is like above 330 nanometer XYZ dimensions, all dimensions, but if it is less than, smaller than 100 nanometer, it's just like a pure nano products, but good to use in accordance with European cosmetic regulations. If there is any nano product, one or two or more than one dimension is smaller than 20 nanometer, or sometimes all three dimensions are smaller than 30 nanometer, then it's nano, pure nano products, and it's not allowed. It's not allowed to use by European cosmetic regulations. So all those things are actually possible shapes that we can actually manufacture. Primary particle size or primary particle shapes that we can actually control, or shapes that we can actually manufacture using Duchenne technology. And we're going to actually talk a little bit about why people are worried about this nano issues. There is a very famous research by Mr. Coulson, McCall, blah, blah. In this research, actually, they talked about like a potential problem of nano zinc oxide in sunscreen. And then those sunscreen nano products are to be accumulated in the body parts more than bigger sized zinc oxide. At that time, the only particle shape they can have from the market, other than just nano, was like a one-dimension non-nano zinc oxide, as you can see right here. We called it like a columnar zinc oxide. And then they kept track of the zinc content in the body part after having people wear sunscreen products, so sunscreen formulas, that they use nano and bulk or non-nano zinc oxide separately. Okay, you can actually go for the. This was like a simple result from their research. This is quite interesting. When it comes to this, like a bulk, it means just like a every size of a 100 nanometer zinc oxide, columnar zinc oxide, and then they put like a 20% content in the formulation. And then for the nano particle sunscreen, they use like a 20 nanometer zinc oxide, the same content, weight percent, like 28%. As you can see, and then they kept track of the zinc material in the body part. They said that after applying those in the skin, they kept track of the content of the zinc material in the body parts. And then, as you can see, especially for the female nanomaterial, nano zinc oxide, sunscreens using nano zinc oxide actually accumulate a lot more than just bulk sunscreen products. When it actually comes to this bulk sunscreen product, it's still two dimensions of the primary particle size is nano, right? So it doesn't mean that it's not going to go into the skin or not, but this has a better chance of being protected, not entering into your skin. That's what they're saying. The second part was the second research that I would like to talk a little bit about is this one, topically applied zinc oxide nanoparticles suppress allergen induced skin inflammation and blah, blah, as you can see. This is kind of a very famous research published in 2014. And I mean, they actually touched many interesting topics. However, they had like a skin model. And then they actually tried to measure try to visualize whether zinc oxide is going to be inside of the skin or for the normal skin condition model, and then for a sensitized skin model. This was a very interesting slide, I guess. PBS is simply a skin model for normal skin condition. And as you can see, this, and then also they use the nano zinc oxide like this. Any zinc oxide with the average size of 30-20 nanometer, and then this is a bulk, another columnar zinc oxide they used. For just like a D and E, D is a nano zinc oxide suspension, the E is a bulk zinc oxide suspension. I don't see big difference here actually, but what they're claiming is that this bulk solution, suspension, has a tendency to stay out or outer part of the skin pore. And then what they're saying here is like you can see a red marks right here. So zinc oxide, even for the normal condition skin model, it gets into the inside of the skin pore. But the things actually change dramatically when it comes to sensitized skin model. Sensitized meaning you actually keep doing some of the scratching kind of thing. It's not like a disease or anything like that. You actually scratch it several times. Just like, we can, scratch our skin all the time, right? For the sensitized skin model, if you actually put nanomaterial suspension, then as you can clearly see, it's all over inside of the skin pore, or sometimes they say that it's actually it's inside of the very lower part of the skin. That's what they say. For the bulk zinc oxide, it stays exactly almost same as what we saw in the normal skin condition. So it does not go into the skin. So based upon this model, they are talking about the potential threat that we're going to actually have when we topically apply zinc oxide on a daily basis. Because nowadays the risk of this kind of problem is increasing, because many people actually worried about demerits of in organic UV filters. So there is a tendency that people are turning to zinc oxide or inorganic UV sunscreen products. So before, they only used a small amount, like 10 to 15% was the maximum weight percent they're going to actually use for the inorganic content like zinc oxide. But nowadays, many people are using like 20 to 25% of zinc oxide in the sunscreen, and then they wear it almost like a daily basis. So the risk of this nano problem is even being increased dramatically. But there is a problem right here. I mean, those two researches were done in fair conditions, because fair comparison in skin penetration or body accumulation was made actually because they actually use the same content of nano and bulk particles in the suspensions or in the sunscreens. However, if you're going to actually measure the UV blocking performance of the same weight percent content of nano or bulk sunscreen, it's going to be, I'm sure that it's going to be extremely different. Nano probably have a better chance of protecting your skin from the sunburns. This bulk, even with this 20% or 25% of the weight content, or even more, are not going to give you as good protection as nano does. So if you're going to actually compare this in terms of your skin protection, then it was not a fair comparison. That is why many sunscreen companies actually are still using nano, because you want to have actually protection first, and you're going to expose to the long-term harmful conditions, because you don't want to actually have sunburns. So it's more like a sunscreen. Bulk sunscreen is safer, but you're going to have a sunburn. Nano sunscreen is a little bit harmful, but it's long-term, harmfulness. But still, in the short-term wise, it's going to actually protect your skin from sunburns. So there's a dilemma, nano or non-nano. I mean, our major object was to achieve both of them, safe and good protection at the same time. There is a fake non-nano concept in the market. It's kind of I don't want to actually call it fake. However, it's our competition, because they're going to actually want to use the concept of non-nano to get the conception of a safe solution. However, the technology they're using is actually exactly the same as nanotechnology. So in order for us to get into the market easily, we need to actually talk about these guys a little bit. There are two different non-nano concepts in the market, in the formulation, sunscreen formulation. many people actually claim like a non-nano, and then in the small words, they say that it's like a non-nano in formulation, non-nano in formulation. Meaning they use the nano material for the sunscreen product. The same nano material that we talked about in the previous researches. Toxicologists actually worried about. The same nano materials. The reason why they can actually use this concept is that nanomaterials, particles usually agglomerate into like a bigger size, like 100 to 100 nanometer in the formulation. So what they do is like they actually measure the size distribution in the formulation, and then claiming that it's bigger than 100 nanometer. So it's not nano. It's non-nano in formulation, but that's what they say. However, this is like exactly same particle, nanoparticle that this toxicologist warned about. So it's more like they're using the same nanomaterial and then get another set of data in the formulation saying that it's non-nano. Another concept is like they actually use mostly nanomaterials and then use only small portion of non-nano particle, like less than 3% at most. Then they claim that it's non-nano particles. So all those things are not real non-nano concept, and it has nothing to do with the worries that this nano toxicologists were worried about. And also none of your interested concerns. We collected some samples from the non-nano sunscreen, and then we actually heat up until we actually see the particles, and it is the same image. As you can see, it's just a clear nanomaterial. It's a typical nano titanium dioxide that you can see here, and this is combination of columnar and then nano zinc oxide, we believe. So they're still using the same dangerous material, and then claiming that it's not nano. So if you don't have any concern about non-nano or nano, it's okay to use all of this, because it's in accordance with the European cosmetic regulation. However, using the concept of non-nano, taking advantage of people's worry, I don't think it's a good thing, And then we have actually tried to resolve these issues with the real solution. We called it like a journey for the real non-nano technology. This is like we're going to actually go back a little bit, and then we're going to talk about the beginning of zinc oxide synthesis technology. At the beginning, all the people like in 1950s or 60s, all the zinc oxide available at the time was like non-nano. It's a bulk. It's a one-dimension columnar zinc oxide was there, at the beginning. As I told you before, as I mentioned before, this doesn't really have a UV blocking performance. So at that time, many people actually use organic filters only. But in 1990s or late 1980s, some Western companies like BASF or other companies actually came up with the nanotechnology, and then they manufacture many different size nano titanium dioxide, and then also zinc oxide. This is like a typical columnar zinc oxide that you can actually see. This technology was have been here for so many years, almost like half decades. Half centuries actually. And this is like a typical example of nano titanium dioxide. Usually, nano titanium dioxide has a very good scattering or absorption in the UVB wavelengths areas from 290 to 320 nanometer. So they add this with organic filters, cheap UVA blocking filters, and then you can actually have a good sunscreens. That kind of sunscreens or formulation were quite popular in 1990s or early 20s. This is like a typical nano zinc oxide that you can get in the market. Anything is around like a 30 nanometer or 25 nanometer, something like that. Even though there is a risk, people will talk about the regulation. We talked about the regulation, and anything under 30 nanometer or anything under 20 nanometer is not allowed in the market. However, people are actually using a lot of like a 30 nanometer or 25 nanometer zinc oxide. There is the reason. Because, basically, when you actually protect your skin from the sunlight, TiO2, titanium dioxide absorption in the UVB sector is higher. And then for the sunburns, this area is more important. So absorption of zinc oxide in the UVB sector is lower than that of titanium dioxide. For the zinc oxide, UVA sector right here, UVA especially from 360 to 380, it's very high. So if you're going to use just a normal zinc oxide, then you're going to actually have a very good UVA boosting. However, not good in the UVB sector. So you're going to actually get the sunburn from this area, and then you're going to get the darkening of your permanent kind of darkening of your skin in this area. You don't want that. You don't want both of them. So you're going to have to actually depend more on other types of scattering rather than Raman. So if it is smaller than 30 nanometer, then you have a chance of getting more scattering. So even if you actually use zinc oxide, you can have a improved quality right here, performance. That's why actually people tend to use something around 30 nanometer. Also, there is another type of scattering called Me scattering. That's actually targets almost same size as the wavelength. So it means that from 30 to 300 to 380, if you have a size of a particle like a 300 to 380 nanometer, that would give you additional scattering effect. So now we understand why people are using like a small zinc oxide. There's a smarter way of improving zinc oxide's performance. There's a company called BASF, and they have a very famous Z-coat product. And in here, they have a mixture of a very small particles like this, probably around 30 nanometer, just like I told you before. And at the same time, they have a columnar product. It means that they have a combination of both of them, and that actually generate quite good boosting in UVA and UVB sectors at the same time. There's another product called ZnO 10. As you can see in the name, it's a 10 nanometer in width, and then it's sort of a combination or a mixture of a nano and then columnar products. And then this is every columnar or nano material has the same width, size, or 10 nanometer, and then the columnar is sometimes is bigger than 100 nanometer, and then the thickness is sometimes bigger than 100 nanometer, and as small as like a 10 nanometer at the same time. So you're not allowed to actually use anything below 20 nanometer, and then for this thing, it's quite difficult to define this as a nano material we can use in the cosmetic regulation or not. So as a result, anyway, this product was very popular in the past, but nowadays there are some rising concerns about this kind of product. Anyway, if you want to actually get the best use of zinc oxide, for the zinc oxide only, it's very hard to achieve high SPF. There was many tries and then technical breakthrough that people want to apply to be real non-nano. So company called like Sakai or many Chinese or Korean companies actually try to expand this small particles to bigger particles like this, proportionally. When I say proportionally, since you're actually making the seed small size particle first and then evenly expanded, this is like the width size and that is thick size, but it actually is the size of the particle, primary particle size, actually maintained almost same like this. As you can see right here, for the titanium dioxide, they try to actually prolong it a little bit. So this is like a C company's non-nano titanium dioxide, but it's very difficult to call it non-nano. However, this length of primary particle is a little bit longer than just typical nano product. And this is another version of non-nano titanium oxide. However, some of them actually has a bigger size than 100 nanometer. However, usually it's still small enough to be called at the same time nano. For the zinc solution, there is a good research performed by P.S. Hale, and we call it P.S. Hale method. And then it's more like a two-step synthesizing methods. First of all, you want to actually make a very small size planetary nano seeds with aspect ratio of almost like 3, just like this, The thickness is 1, and then this width is like a 3, 1 to 3 kind of a planetary seed. And then this actually, when you actually made it in the hydrothermal reaction from the zinc salt in the methanol solution, you cannot even see the seeds. It's not, it's almost like a pure, clear solution. And then you're going to actually expand the seed into the non-nano size through, the precipitation of zinc salt by strong base, like, potassium hydroxide or something like that. And, you have big size zinc oxide. So it's like the width of a 100 nanometer usually have, thickness of a 30 to 40 nanometer. But, as the size goes up, thickness goes up too. It's a revolutionary technology at the beginning. However, it still have a lot of limits because, as the size bigger and then the thickness goes up, which means that the PET is very small. So you're going to use this powder, but the performance of UV blocking is not there. So it's non-nano, pure non-nano sometimes, or at least 2-dimension non-nano for the most cases. However, it does not give you any UV blocking performance that you are looking for. What we have done as a company was to maintain very thin thickness of the particle and then try to actually expand the particle to horizontal direction. So now we have like a 20 to 30 or, sometimes like under 10 nanometer thickness, very thin. And then you can actually make it from 100 nanometer to, 1,000 nanometer as we want. So this is like one example of what we call the ultra-thin planetary zinc oxide, UTPZ, the way we call it. We have our core technology in zinc air battery, and then when we run zinc air battery very efficiently without any side effects, then you can have a pure supersaturated electrolyte from the battery, and then we put it in the precipitation reaction, and then we have a one single step precipitation reaction, and then we can actually maintain this thin thickness, and then we can expand it to, for this case, it's like 1,000 micrometer, but we can actually control it from like 100 to 1,000 nanometer. So it's basically two-dimension non-nano product. The reason why two-dimension is very important is that when we actually check the nano toxicologist worries, they worried about the penetration of the nanomaterial into the skin. However, and then they actually compare nano with the columnar zinc oxide. But columnar has a small size, like a 50 nanometer in the width. Two dimensions are like still small enough to get into the skin, you know. But if you have like a planetary zinc oxide, bigger than, of which two dimensions are bigger than 100 nanometer, or then any cutting edge is bigger than 100 nanometer, so that it can get into the skin easily. So even though it's just still nano, like just two-dimension nano, non-nano, we believe that this is our core technology, basic technology, that we minimize skin penetration of zinc oxide into your skin. However, we changed all different combinations of the thickness and then width and everything, but with this using just only this product only, we failed to actually achieve high SPF. So also when it comes to the powder itself performance, I don't think it's better than nano. It's a little bit lower than nano. We can actually have very good product, but not as good as nano in terms of the performance. So the next step we have taken was like we tried to actually structure this UTPZ in the structured way with the vertical walls. We believe with the vertical walls, it has a better scattering effect. What we have developed was like this structure. As you can see, every primary particle is UTPZ, ultra-thin planetary zinc oxide, with the size about 150 nanometer, and the thickness is like a 20, very thin. But we structure the primary particles into more like 20s or 30s in a structure that has vertical walls like this. With this structure, we believe the scattering of the light UV can be maximized. If you actually compare the performance of this powder when it comes to the absorbance of the powder, I think it's safe to say that it's better performance than most of nano zinc oxides. However, if we actually put this in the formulation using this type of powder only, we cannot get high SPF when it used alone. The good news there was like we actually tried it with many different kind of nano or non-nano, other types of products, and then we came up with the specially designed columnar zinc oxide that we can actually use it together with this structured UTPZ, and then we got SPF 40 and PA3 plus products. When it comes to the industry standard or customers' expectation from the market, they expect like SPF 40 or 50 or PA4 plus products. However, it has been almost extremely difficult for us actually to get this kind of a result using only non-nano products only. And I believe we actually figured out the factors influencing the SPF performance, so that we are actually coming very close to SPF 50 or PA4 plus. I can't say that we can easily achieve PA4 plus. However, I think SPF 50 is around the corner, I guess. I believe. This is like a simple example of what we had. This is like a in vitro transmittance result. And as you can see here, structured UTPZ and columnar individual transmittance. The lower the better, because it is a transmittance of the formulation, the cream that we use, right? So individually it's high like this, but when we have a mixture, then it actually decreases like this. Also, we compare all this with the nano columnar mixture. If you remember, you saw the data from the G-coat or ZnO 10 or something like that. It's basically nano and columnar mixture. We chose many different types of nano columnar mixture, and then this was a structural UTPZ or a columnar mixture. So if you're going to actually use the same columnar, if you're going to use a structured UTPZ, you have a better result in terms of the synergy we have. So this is just like a simple example of what we have. And we believe that we found all the detailed factor that we can actually apply further to get better performance in the near future. Other than us, there are some other good companies trying to actually have all-dimension micron technology. We believe this is all-dimension micron technologies too, because in-group, in-bond, infused groups bigger than 100 nanometer in all dimensions, right? Similarly, Korean company called Koreana actually have their own technology to physically or mechanically coat big sized product or zinc oxide with the small nano product like this. This is actually a big size zinc oxide that they used was actually our Toxicologists very large UTPZ, and they put a small size nano zinc oxide on the surfaces of these UTPZs. But unfortunately, without using additional nano products, they couldn't actually achieve high performance. So I believe they use almost around 10% of nanomaterial additionally to achieve that SPF 50. So it's, and there is another benchmark. There's another company called Croda. They came up with a technology called MICNO. And then it seems like that they combine all those small fake-shaped planetary zinc oxide vertically and then horizontally. Since we have a very limited information, We don't know whether it is like a mechanical or chemical bonds. However, what they published in 2020 is that they achieved like in vivo SPF 20 when they had like a 28% of use of this powder in the formulation. So SPF 20 is a good number, but no one's gonna actually use this to protect your skin from sunburns. So I think we still have to shoot for SPF 40 or even more. And then since this actually technology requires deliberate, as you can see, it largely depends on many different types of scheduling. You're going to have to actually have a deliberate control of your size. So something around 30 has to be there, and then any other size need to cover like 300 to 380. So we believe that this this has all the figures here, and then if you're going to actually use it like a columnar zinc oxide with size of 30 to 50, along with this thing, it actually maximized UVB blocking performance. So this is a simple example of what we have done so far. And then we have found out many other surface coating technologies that controls the release of zinc ion fast or slow kind of thing. Along with this technology, we have been backed up by Korean government. We got the R&D fund from Korean government about 2 million US dollars for 3 past years. And then right now we have a pilot production scale, and then we are ready to jump into the market if we have the support from the massive marketing company with the big brand, I believe. Someone who actually sees the value of non-nano along with us. Thank you.